Okay, have a good day. Grade 9. So this I made this video for those who having online class, and it is your time to check this video so that you can understand the topic, the projectile motion and momentum. But first, we need to start with what we call momentum. To start with that, we're supposed to have this activity in our face-to-face class. We have this activity, but we're going to skip this for the meantime. So these are the components that you need to take note for the projectile motion. It is very simple formula. So acceleration, always take note that when it is horizontal, it moves like this. The acceleration is zero. And when it is vertical, the word vertical, that means that goes down, that goes up, vertical. That means it has with connection with gravity. That is why we have acceleration due to gravity. And that certain acceleration due to gravity is always taken for this, is always 9.8 meter per second. And it's in the projectile motion, it will be negative because anything that goes down will become negative. Now, let's have, okay, again, I'm going to annotate here. Again, this one is 9.8 meter per second. Take note for when it is acceleration, there is a squared and the second squared. Okay, you put that in your mind. So now, let's have the velocity. In horizontal, velocity is with connection with the cosine angle when there's a specific angle given. Like for example, this one, there is an angle that was when you need, if you wanted to solve the velocity in its horizontal, the moving horizontal velocity, the velocity, the speed, or yeah, the velocity. When you're talking about velocity, it's respect with distance and time or displacements divided by time. So it goes like this, horizontal. And it has a connection with its angle. So, and that is why we're going to use cos. And to take note for that, it connection with your math topic about SOHCAHTOA. So, and here in the vertical, we're using about the sine angle. You use the angle that is given and then you multiply. So that is for the vertical. While for the velocity, in other words, here, always take note that this one, the word x here is mean that it is horizontal velocity. Always take note that horizontal velocity is equals to the zero here in the shape states initial. X is always word as horizontal. Initial horizontal velocity. They are equal. So what is your horizontal velocity is same with your initial horizontal velocity. They are equal. But in velocity, it's a different thing because you need to deal with the gravity. That is why we have this formula. The gravity and has time. So initial, um, let's start vertical velocity is equals to initial vertical velocity plus gravity times time. Why we need the gravity? Because when it goes up or its velocity, there's a deal with the gravity and it has its time also with its connection. So that's why we need to use this formula. I hope that's very clear. Now, we're talking about displacement. The word displacement again, it is a certain range or where the certain object falls. So that is in horizontal, displacement is equals to velocity times time. Since we have here x or horizontal velocity, so it should always have your distance is also x because horizontal distance. And here in displacement, actually, vertical displacement is also different from horizontal displacement because this one again vertical it deals with that goes up, it goes down. When it is vertical velocity, it should be a negative ang yang displacement. All right, you take note for that. So this is the formula: velocity, initial vertical velocity times time plus 1/2 gravity times squared. So this one, we usually use this formula in solving displacement when there is no given angle. Like for example, in a certain scenario, this is the cliff, and there is no form of angle and it falls down directly, that is what we call a projectile motion. It's horizontal velocity, or projectile, or it's also known as thrown horizontal projectile. Okay, thrown horizontal projectile. That's it. Okay, I hope that's clear, and we need to move forward now. Now, since we are done with those topic, okay, let's discuss the projectile motion in its whole concept. So earlier, they just highlight on it, but you always take note that the motion of the body projected horizontally or an angle of 90 degrees with a horizontal is called projectile. So when there is a 90 degrees with horizontal, there's an angle, again to write it here, this one. This is what we call a 90 degrees. 90 degrees and 90 degrees. Motion body projected horizontally or at an angle of 90 degrees. This here is having 90 degrees, right? That's 90 degrees. Okay. Yeah, that's 90 degrees. I just need to go and make sure. Yeah, that's correct. Now, Galileo Galilei described components horizontal and vertical. So first, Galileo Galilei described this in different things. When it's horizontal, always take note that the motion is uniform. What is your motion? Like, for example, this is the car. What is your motion moving? It's the same motion. If you want to stop, then you have a change or you have decelerates. Or if you slow the speed, but it's a uniform motion. Doesn't affect anything, but sometimes it may be depending on an object. But this one, talking about horizontal motion, there's a uniform motion. Wala ko siya na hilabtan. All right. When vertical, it is what we call the free fall that we're having acceleration equal to gravity of 9.8 meter per second squared. So vertical, when it free fall, it always connect with 9.8 meter per second squared. The path of projectile is called trajectory. When talking about trajectory, from this one, the path, and form parabola. Okay, that certain one is what we call trajectory. Kinidin he padong diha. It's called trajectory. The path as nga agian ni diha. Huh? Okay, I hope that's clear. Now let's have let's move to the next part of the discussion. So, the kinematics of projectile motion. These are the few concepts lang that we need to remember. I hope you're going to copy this. So, kinematics projectile motion, when it is a V0, always put in your mind that is called initial velocity. When it is V0x, it's called initial horizontal velocity. I think I already discussed this earlier. And then initial 0y and v0y, it's that what is called initial vertical velocity. Okay, the following sign convention shall be used. These are the distance above the origin are positive, while distance below the origin are negative. So like for example, the distance okay, the distance above the origin are positive, while the distance below the origin are negative. So, like for example, this is this is your path of projectile. Your distance from here to there. Always take note. Distance above the origin. So this is your origin, your distance. It goes there at the top. That is always be positive. Positives, yeah. Once, in projectile, always take note for this. Once this one, kana siya, no? And this is your origin of distance or your object. And it goes down here. It goes down there. And so what happens, since this is your origin, it goes there, your distance will become negative. Okay? Put that in your mind. There is a different thing. Always think that the distance in horizontal is positive. When distance in its vertical, that is be negative. Okay? So Upward velocities are positive, so it's the same thing. When upward velocities that goes up is positive, while downward velocities are negative. From here, going there, bang, your velocity should be, you should always take note that the velocity from here to there is negative. Okay, below man, below. Velocities, downward velocities are negative. And it goes up, like for example, this is the what happened for projectile motion, goes up there, it is positive. And since it goes down another hard, it is become negative. So that is what we call velocities in its components. Now, acceleration due to gravity is always negative, okay? That's why in your formula next time, if you wanted to add acceleration, you always put the acceleration into negative 9.8 meter per second squared. Always put in your mind that the unit is very important in solving a problem. Put that in your mind. I hope that's very clear for you, everyone, because units matters in solving a projectile. Even in any mathematical equations or scientific equations, it should be included because the unit are the expressions of your numbers. What they express, they just numbers. There's no unit, so if there's unit, then you can include, okay, this is the velocity, okay, this is the distance. So you need to include the, again, okay, need to include the unit. Now let's move. Horizontally thrown projectile that I've mentioned earlier. When an object is launched horizontally, such as ball, thrown horizontally off a building, the angle of a projection is zero. The initial velocity of the object is its initial horizontal velocity. Okay, this is now what happened. Okay, people. Okay, this one. All right. Saya giingon. Okay, look at this. When an object, this is the, okay, how to demonstrate. When an object launch, this one, horizontally, such as ball thrown horizontally off the building, like for example, this is the building, thrown off the building, the angle of projection is zero. So there is no projection because the projection is look like this, bang, right? See, yeah, diba? That's the projection. But when it goes, rolls off, it goes down, there is no projection. There is no angle of projection. So your angle of projection is zero. I hope that's clear. It's different thing when this ball goes up there, it creates an angle. But if it goes like this, okay, look at that. It goes like this, bang. That is no angle of projection. I hope that's clear. Now, the initial velocity of object is its initial horizontal velocity. So, in this case, what is your initial velocity or V0? In that case, your horizontal velocity, the Vx, is, once again, its initial, sorry, let's razor x. It's equal to the initial velocity of its object and its initial horizontal velocity is equal. They're the same. If what is your initial velocity, that is also your initial horizontal velocity. Okay? Now, let's move. Sana naman ay di na. Nalingaw ako discuss niya, guys. Kaya now I love my students. Okay. All right. Now, let's move. So the projectile launch at an angle is a different thing because earlier in the horizontally thrown projectile, it is no angle, but in the projectile launch at an angle, it has an angle. Definitely because projectile launch at an angle. So it look like this. There is what we call like that. The ball goes up, goes down. You need to resolve the initial velocity into horizontal and vertical components. In this case, you need to solve, if you have V0, you need to find the initial V0x initial horizontal velocity and v0y. And that is the time that you need this formula earlier that what we used, like the v0 is equals, no, sorry, v0x is equals to v0 cos angle. That's the time that you need to use. So angle of the projection times the cos times the initial velocity, and that is your v0x, the initial horizontal velocity. When it's cos, that is initial horizontal. When it's v0y, if you wanted to find your initial vertical velocity, you use this formula class, v0 and sine. Always take note for that. Sine, then angle. All right? Angle. So the angle of projection is given, like for example, 30 degrees times the sine times the initial velocity that is given. Okay? Okay. Okay, okay. So you don't know. Now you use those. Now, sorry. I need to erase this. Okay. I'm sorry. Oh, sorry, coach. On whiteboard. Right. I hope that's very clear. Okay. Now, the projectile motion and sports, there's still a connection. So, like for example, you wanted to, can involving throwing or checking the object such as ball. So there's also a motion. There's a projection. So it's like that. That is in a sports. But it's the same process. There's an angular projection. Same process for what you are going to do in projection with an angle. All right. Since we are done, we are going to solve now. The we are going to solve now a problem. Okay, let's start with this one. Okay, maybe we have this in the second part of the video, so keep tuned. Bye everyone. I'm going to give you the tutorial video for how to solve a problem. So later on.